Hey guys, and welcome back to another video on the channel. In today's video, we're going to be learning how to solve some logarithmic equations. So, log is basically the inverse of an exponential. Now, to solve some logarithmic equations, there's a couple things you need to know. So, if you have the form a to the power of x is equal to b, you can rearrange this and put it into the form of a log. So, the way you rearrange this is you take this, and you're going to make this equal to, this now becomes the base of our log, so log of a, and then this goes inside our log, so of b. So x is equal to the log base a of b. So this is the first most important thing with logs, is being able to flip between an exponential form and a log form. Now there's a couple other laws, so I'm going to move this to the side and refer to this throughout the video, hopefully. And let's move that there. There's another very much law. If you add two logs and they have the same bases, you can pretty much multiply what's in the middle. So in other words, if you have log, let's stick with the base a. So if you have log of a, of x, and x can be anything, it could be a number, or you can leave as a variable, and if you add it with a log that has the same base, so a, with y, you can effectively put them all in the same log and multiply x and y by each other. So what I mean by that is this is equivalent to log, oh, my pen was glitching, log base of a of x times y. So all you can see is we combine them into one log and we multiplied x and y together. Okay. Now, likewise, we have the opposite, well, not opposite law, but a counter law as well. So if you have log base of a of x and you're minusing the log, so log base of a of y, it's going to be divided instead. So we'll have, this is the same as log base of a over x divided by y. Okay. So exact same idea, except if it's a plus, you multiply what's inside the brackets. If it's a minus, you divide them. Okay. Now I'm going to put these to the side. So these are probably the main log laws. Oh, another important one. If you have, let's say you have x, let's say we have 2 to the power of x is equal to, let's say, 4. Okay. If you take the log of both sides, whether it's natural log or log of any base, as long as it's the same base on each side, you can take it. Natural log, so ln, is log to the base e. Okay, so that's another point of reference. So if you take the natural log of both sides, so log of 2x is equal to log of 4, you can actually bring this exponent down the front here. So this is equivalent to basically x log of 2 is equal to log of 4. And then you divide both sides by natural log of 2, and that gives you x. Now in this case, x is going to be equal to 2. Because if you put 2 in here, 2 squared is 4. Boom, too easy. Righto. In more general terms, I'll replace this with some variables, or a variable here. I'm just going to write it like this. So if you have a to the x, and you take the log of that, that's equivalent. So I'll move this up here. So hopefully you'll be able to follow that. So I'll put that to the side there. Those are our main laws, okay? And probably this here as well. So let's get to solving some logarithmic equations. So let's do our first one here. So let's just say we had, I don't know, let's say log with a base 5, and they'll have in the brackets 2x plus 4 is equal to, let's say, 2. So if you want to have a go at solving this equation, feel free to pause the video and have a go. Alright, so the way we start off this equation is we'll start solving this is we're going to use this law here, or this law here. Because we can't really do anything because we want to get x by itself, but in this form we can't really do that. So what we're going to do is put it in exponential form. So in other words, we're going to have this is be our bottom bit, and we're going to raise it to the power of 2. So you see, what we've taken here is taken our base, so our 5, which was our a, and put it here, and that's equal to 2. So 5 squared is equal to all of this, so 2x plus 4. 5 squared, that's going to be 25. I'm going to move the 4 to the other side, so it's going to be minus 4 is equal to 2x. So we have 21 over 2 is equal to x. Boom, too easy. Right, let's have another go at a simpler, well, not a simpler one, but a more complex one that deals with a couple more ideas. So that one, you just use this one pretty much and you solved it using just algebra. So let's say we had, we can use natural logs as well. It doesn't have to be log to the base 5. We can do ln, so this is a shorthand for log to the base e. So let's just say we have ln of 7 minus x minus 10, log of 10, is equal to log of x. How are we going to solve this equation for x? So if you want to pause the video, have a go at this problem, and then I'll get solving to it. Alright, so straight off, we can recognize we can simplify this entire bit here via using this law here. So we can simplify the left-hand side and say, alright, natural log of 7 minus x divided by 10. Too easy. Now, here's a trick you can do. If you've got a log acting on this side and a log acting on this side, you can actually cancel out the logs, because log of all this is going to be the same as log of all this. So basically what this is saying is basically all of this here must be equivalent to all of this here. So we can basically rewrite this as saying, alright, 7 minus x over 10 is just equal to x. So in other words, we have 7 minus x is equal to 10x. So therefore we have 7 over 11x is equal to x. So I moved the x over here, so that became 11x, and I divide by 11, so 7 over 11 is x. Cool. Alright, let's have another go at another one. So, rub that out. If you have any questions at all during the video, just feel free to leave a comment and I'll try my best to respond to it. Alright, let's have a go at another one. So let's say we had log, and let's say base 10 of x plus 3 is equal to, actually no, let's go plus log of 10x. And let's say it's not equal to a log. Let's say it's just equal to 1. Okay, so if you want to have a go at this, feel free to pause the video and have a go, and I'll get started. So straight off the back, we're going to use, which law are we going to use? We're going to use this one here, aren't we? Because we're adding 2 logs here. So if you can recognize that, that's good. So that means we're multiplying x by x plus 3. Now, the x is going to be multiplied by the x and the 3, not just the x. So we rewrite this as log of 10 of x squared plus 3x. So in other words, I did this step in my head. I wrote it like this in my head. And I distributed the x, so that gave me that is equal to 1. Now we're going to use this law here. So we rearrange this and we're going to have 10 to the power of 1 is equal to x squared plus 3x. So if you don't know what I just did there, I just used this log law here on here to rearrange it, because we can't do anything if the x is inside a log. So what we're left with is pretty much a little quadratic here. So x squared plus 3x is equal to minus 10, sorry. Minus 10 is equal to 0. So how can we solve this equation? Well, we need to think of 2 numbers that multiply together give negative 10, and 2 numbers that add together give 3. So straight off the back, I'm thinking 5 and negative 2. So if you add these 2 numbers, that gives you 3, which checks out that. And if you multiply these 2 numbers, it gives negative 10. So in other words, our solutions are x plus 5. Well, not our solutions, but if we factorize x plus 5 and then x minus 2. So therefore, our solutions are going to be x is equal to negative 5, and then x is equal to 2. Now, here's a trick. Can you log a negative number? The answer is no. You cannot log a negative number. So if we were to consider x is equals negative 5, if we were to put it into here, this would give us a negative log, and so would this. But would that work as well? Actually, yeah. Well, effectively, this is a solution, because when we combine these 2 logs together, like if we didn't have this bit here, then it wouldn't be a solution. But since we have this bit here, we can combine those, and that will just give us this expression here. And if we put negative 5 into here, that's just going to give us 0. And log of 10 of 0 is 1. So yes, this is a solution to this equation here. If we didn't have this term here and we put the negative 5 in here, then it wouldn't be the solution. But effectively it is. So these are both valid solutions. Okay. Yeah, that was a quick little video on log equations. If you have any questions, feel free to leave some in the comments. If you want more videos like this or any specific topic you want to cover, just leave a comment and I'll make that on that topic. I am looking for new ideas for this channel. Mostly I'm just going off what I think is interesting at the moment. But anyway, thank you for watching.